All right, in this video exercise, I'm going to show you how to identify and find what in fact is not a spanning tree. We have 4 elements here, we have 4 diagrams, and we want to determine which one is not a spanning tree. But first, let's talk about what is a spanning tree, because 3 of them is going to be a spanning tree. A spanning tree, you know you have a spanning tree when you have one pathway between any 2 vertices. The second thing about spanning trees is that all vertices must be connected. So in other words, if you have one vertex over here and it's not connected to the others, then it's not a tree. And thirdly, there is always one less or one fewer edges than there are vertices. For example, if we want to confirm the third part that I just mentioned, a spanning tree, if it has n vertices, it'll have n minus 1 edges. In other words, it'll have less edges by 1 than it has vertices. So they're the criteria. So let's go through these diagrams and see if we can determine which one is not a spanning tree. So let's look at the first one here. The first one here, it looks like we have every single vertex connected. So it looks like a tree so far. We don't have a cycle in it because you can't have a cycle or a loop. So that looks like a tree. Let me count the number of vertices. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices. So there must be 1 fewer edges. Let's count the edges. 1, 2, 3, 4, 5, 6, 7. Yeah, there are 7 edges. Which means, yes, this is a spanning tree. So that has the criteria. That's correct. That's a spanning tree right there. All of the vertices are connected. Let's have a look at this one over here. Okay, what do we got? Well, let me count the vertices first. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 vertices. So we should have 1 fewer edges. Let's count them. 1, 2, 3, 4, 5, 6, 7. Yes, we have 7 edges. So that looks like a spanning tree. Now all the pathways are connected and every single vertex is included. So yep, that's a spanning tree. I'll put a tick. That's a spanning tree. Every single vertex is included. Let's go to the next one now. We're looking at this tree right over here. So let's count the number of vertices. 1, 2, 3, 4, 5, 6, 7, 8. Notice this by itself. 8 vertices. So far it doesn't look like a spanning tree. 8 vertices. I'll just put a V there for vertex. So we got 8 of those. The number of legs or edges, 1, 2, 3, 4, 5, 6. We have 6 edges. Now we have edges 2 less than we have vertices, so that can't be a tree. It needs to be 1 less. It's kind of obvious because one of the criteria for a spanning tree is that between any 2 vertices there must always be a pathway or an edge. And there is no pathway or edge between this vertex and any other vertex on this tree. So this is not a tree. Not a tree, not a spanning tree. So I'm going to highlight that. So be wary, this is not a tree. Let's go to the next one. It does look like a tree because every single vertex is connected and between any 2 vertices we have a pathway. So yes, we do have that. All vertices are included. There's no vertices or a vertex hanging out here like the other one. We have no cycles. And they're all connected. Let me just count the number of vertices. 1, 2, 3, 4, 5, 6, 7. 7 vertices, I'll abbreviate it. 7 vertices. Let's count the edges. There should be 6 if this is going to be a tree. 1, 2, 3, 4, 5, 6. Yes, we have 6 edges. E for edges. So yes, that is a spanning tree. So again, the spanning trees, that's a spanning tree, that's a spanning tree, that's not a spanning tree, and that's a spanning tree. Hope that helps.